Carlos has the actual password that the application should use on his developer workstation. Now he'll configure the application connection string. But he won't put that password into app settings JSON because he needs to ensure that he doesn't check any secrets into source control. Instead, he will store his application credentials in user secrets. This technique will work for him and his team as application developers, but this is not for shared environments. He'll address that problem shortly. User secrets are app settings that are stored outside of the source tree. That prevents them from accidentally being committed to the repository. Carlos edits the app settings JSON to leave a note for anyone who might follow to store the connection string in user secrets. Anybody who runs the application from this state will not be able to connect to the database. When they go to investigate, they will see the note. And so now Carlos will follow his own advice. In Visual Studio, he selects Manage User Secrets on the startup project. Visual Studio will open a file called secrets.json in a folder on Carlos's hard drive outside of the source code repository. The folder name includes a user secrets ID, which Visual Studio added to the CS.proj file. If you're using Visual Studio Code, then you can install the extension .NET Core User Secrets. It manages user secrets in a way that's similar to Visual Studio. Just right-click on the CS.proj file and Manage User Secrets. Alternatively, you can manage user secrets from the command line. Install the global tool .NET User Secrets. Initialize a project in order to create a user secrets ID, and even set values directly from the command line. Use a colon as a path separator when you're using this technique. Or, if you're editing the file directly, you can just use the more familiar nested JSON object syntax. Next, Carlos needs to tell ASP.NET to add user secrets as a configuration source. This configuration source is only valid for local development. He provides the name of a class in the startup project so that the runtime will look up the user secrets ID from that assembly. It will then load from secrets.json first, and then fall back to app settings JSON. And now when Carlos starts the application, it's able to read from the GloboTicket database. It connects using credentials that are kept only on Carlos's machine, and those credentials are given only the privileges necessary for the application to run. Carlos is storing developer credentials in user secrets. Now he needs to keep secrets in shared environments like test, staging, and production. So now, does he store those secrets in environment-specific app settings JSON files? No, I didn't think so. Those are checked into source control as well. You definitely don't want your production database credentials in source control. Instead, if there are secrets to be kept, they should be stored in the most secure way available to you. Several different options are open depending on the target environment. For environments in the cloud, favor secure storage solutions like Azure Key Vault or AWS Key Manager. Not only are those stores encrypted, but they also offer features such as automated password rotation. For environments managed with Kubernetes, consider investing in management solutions such as HashiCorp Vault rather than relying upon Kubernetes secrets. Kubernetes secrets are not secret at all and can be viewed by anyone with access to the control plane. But if no other options are available, then there are always environment variables. An environment variable using a double underscore as a path separator will override app settings. These are your options if there are secrets to be kept. But that was a trick. The best way to secure a shared environment is to have no secrets at all. You see, Carlos is deploying his application to Azure, and so he has the option to secure database connections using Azure Active Directory. Carlos has security locked down in development. Now he needs to secure database connections in shared environments. He deploys the application to Azure. We'll see how to set up continuous deployment in the next module, but for now, Carlos has deployed the application and database manually. Next, he configures a managed identity for the app service. This will allow the app to connect to the database with no password. And finally, he'll set the connection string and test the app. the application is deployed to a shared development environment. The ASP.NET Web application is running on a Linux app service, and the database is hosted in Azure SQL. Carlos can browse to the app and execute the endpoints via Swagger. The application, however, is throwing an exception. When he investigates the application logs, he can see a network-related error trying to connect to SQL Server. And that's because the application is still trying to use the default connection string from app-settings.json. That connection string uses server local, which of course isn't going to work in the cloud. So let's fix that. Carlos wants the application to authenticate using Azure Active Directory so that he doesn't need to manage a password. This feature was enabled in Microsoft.data.SQL Client version 3. He has added the newest version of that package to the infrastructure project before deploying. So he's currently at version 4.1. Now he needs Azure to add an identity to Active Directory specifically for the app service. Carlos navigates to the app service and clicks on the identity blade in order to create a system-assigned identity. Now Azure will automatically authenticate connections from that app service. Next, Carlos needs to create a database user tied to that identity. So he logs in to the application database using Azure Data Studio as an administrator. And then he creates a user inside of the GloboTicket database. Since he's using managed identity, the database user must have the same name as the app service. And he specifies from external provider so that it will use Azure Active Directory in order to authenticate that user. Then he adds that new user to the GloboTicket app role. Remember, he set up that role in migrations in order to grant the application the minimum privileges that it needs. Then finally, Carlos needs to set the connection string in the app service. The connection string identifies the database server, and it uses Active Directory default authentication. And now when he hits the endpoint, the application is able to connect to the database. Carlos is able to authenticate database connections in shared environments with the minimum amount of management. Carlos has put together a plan to keep GloboTicket out of the news. He will secure his databases following the principle of least privilege. He will grant each actor only the privileges that it needs in order to perform its functions. To do that, he configures a database role specifically for the application. This role only has permission to run data manipulation language statements. Migrations need elevated privileges, so he creates a design time DB context factory in order to provide a different connection string. Then he shifts his security position left. He makes decisions earlier in the software delivery process to engage more of the team and find issues sooner. He starts right on the developer workstation by encouraging each developer to generate their own credentials and store them in user secrets. Finally, he applies the strongest available secrets management for shared environments. In his case, he's using Azure Active Directory to avoid managing any secrets at all. Now, there are no guarantees against exploits, but Carlos has taken a strong position to secure the databases that are in his care. Hello, and welcome back to Entity Framework Course 6, Best Practices. I'm Michael L. Perry. We'll need to account for schema evolution as we automate our build, test, and deployment processes. Let's do that with migrations. Migrations have long been a part of the Entity Framework story. They offer a way to incrementally evolve a database schema as we develop new features. They're an extremely powerful tool during development, generating schema changes from code-first models and letting developers upgrade and downgrade their local databases. But when it comes to shared environments, the best way to use migrations becomes a little less clear. You can't just run .NET EF database update in production. You don't have the source code. And how about testing database persistence? How can you make sure that the automated tests are running against a properly up-to-date database? As we automate the CI/CD pipeline, we'll want to test persistence with integration tests. And we'll want to isolate those tests from shared environments so that they don't interfere with QA and user acceptance testing. Furthermore, we'll want to update the schema on the shared QA, UAT, and production environments to match the software that's deployed there. That's a lot to consider. There are many options for automating the deployment of migrations in integration tests and shared environments, and one popular solution is to generate an idempotent SQL script. The script will upgrade a target database to a desired migration, but it does have some limitations. These limitations lead many people to instead run migrations programmatically. You may have seen advice to run migrations on application startup. This is problematic for a number of reasons. The first of which is the principle of least privilege, as we've already discussed. And the second is that a cluster of applications starting up simultaneously will all try to upgrade the database at the same time, which can cause quite a mess. My favorite solution in the past has been to create a separate console application that calls migrate with elevated credentials. This gives you more control over the timing and security of migrations, but it comes at a cost. You now have to maintain another project. EF Core 6 introduces a new, long-awaited mechanism, migration bundles. A migration bundle is like the console application that you might build yourself, but you don't have to maintain it. They're well on their way to becoming the recommended best practice for deploying migrations in integration tests and shared environments. Idempotent SQL scripts and console applications are still good options, but we'll focus on migration bundles. Have you ever wished that you could just wave a magic wand at a shared database and say, schema updatum? Well, we don't have a magic wand for you yet, but migration bundles are the next best thing. When you run .NET EF Database Update, you're using the .NET SDK. It will first build your project, and then it will construct a DB context using your design time DB context factory if available. It's the perfect solution for a developer workstation. But shared environments don't have the .NET SDK. They use the .NET runtime. And they can't build a project from source code because you didn't even deploy the source code to these environments. So just like we build and publish our source code to run in a shared environment, migration bundles build and publish our migrations. To create a migration bundle, you run the command .NET EF migrations bundle. It's similar to other .NET EF commands in that it needs to know your migrations project and your startup project. Specify your migrations project using the -p argument and the startup project with -s. Just like other .NET EF commands, this one uses the design time DB context factory to create a DB context. So in our case, that means that we need to define the global ticket admin connection string environment variable so that it can run. But this command doesn't actually connect to the database. It just creates an executable that runs the migrations. On Linux, that executable is called efbundle. On Windows, it's efbundle.exe. This executable will create a DB context in the same way as your startup project. So if the startup project configures a container to create the DB context, then the migration bundle will as well. And that usually means that the migration bundle needs appsettings.json so that it can find the connection string in configuration. But even that connection string is not the one that it uses. If you specify the -- connection parameter, then the executable will change the connection string in the DB context after it has been constructed. So, to use a migration bundle, make sure that the appsettings.json file is in the same folder, and then execute efbundle -- connection admin connection string. The migration bundle that you create in this way will still require you to install the .NET runtime. But if you really want to minimize your dependencies, you can include the .NET runtime right within your bundle by using the -- self-contained flag. You will often use the -- target runtime, or -r flag, in order to specify which operating system to target. And then you run it as you did before, but now it's pre-built specifically for your target environment and does not require .NET to be installed.